Okay, now can you hear me? Do we have audio, guys? Cool. So, this is my 5th lectorial this week, and I cannot believe I managed to get through the whole week with no technical problems until today. It's not fair, it's Friday. Are we good, guys? Cool. So what I'm looking for is a whole stream of yeses to make sure that everything's okay at all times. So, hi. That was a bit of a technical, funny start there. I'm Dr. Elizabeth Kiriakou. I am your course coordinator and your program manager for BH126, Common First Year Engineering. So if you have problems on your first year program, just let me know. So Introduction to Mechanical and Automotive Engineering is a prerequisite course for all the students who want to move into mechanical engineering, automotive engineering, aerospace engineering, manufacturing and mechatronic engineering, and sustainable systems engineering. Yep. So what we're going to do today is we're just going to quickly run through Canvas and have a look at what material you should have, what you should be able to access, a little bit about the course, what you'll be doing for the semester, and then the second half of Lectorial we're going to start looking at some mechanics problems. So what I'm going to ask you to do is just write your questions in the chat if you have any questions, and I'll answer it here on video. So let's start. So we'll take a look at what your Canvas shell looks like. So this is what you should have for Canvas. I've tried to keep it as simple as I could possibly keep it. So basically what we have is you're pretty much given 3 documents for the semester. Okay, there are 3 documents. Your first document is a lecture notes. So that is all the lecture notes for the semester. So from week 1 to 12, you won't be receiving any more lecture notes from me. This is it. The second document is a tutorial workbook, which has all the tutorial problems from week 1 to 12. And you need to bring this book to all your lectorials and to all your tutorials, because we'll be solving the problems in this book in both lectorials and tutorials. Have all you guys been able to download the PDFs? By any chance? And then finally, your third document, which I have not made active yet, it won't be active until next week, is your Design Studio workbook. The reason why I have not made this active is I think you've got enough material to keep you going for the week. There's a lot of information this week, and you've got 3 other subjects, and we can deal with this next week. Are you guys good? Maybe? Anyone? Right. So let's take a look at, just quickly, while I'm still holding this book, we are going to be working in groups. So the way the Design Studio is set up is that there are 9 workshop groups, and in that 9 workshop groups we have smaller groups of students being working in groups of 5 or 6. You'll be allocated into those groups, and 3 groups will be working on building an additive manufactured, a 3D printed truss. 3 groups will be working on a laser polymer cutting bridge, and 3 groups will be actually metal laser cutting and bending and riveting their bridge. So the idea is to have, you know, lots of different types of manufacturing processes. So you'll be designing CAD, which you'll also be using SolidWorks in my class. If you don't want to use SolidWorks, I'm totally fine with that. If you want to use Fusion 360, that's okay. But since you're already doing Creative CAD this semester, I thought it was a good opportunity for you to pick up your CAD skills. And if you can't use CAD, that's fine, you're not supposed to. I have tutors who will be able to help you do that. So the way the course is actually, and then the bottom link is to the YouTube videos, but you should just be able to Google me on YouTube and it's there. I can't believe I'm a YouTuber now. How times have changed. So if we take a look at your lecture book material, everything you need to know about this course is in this book, okay? Can everybody download this? Have I already asked that question? So we'll take a look at your lecture notebook right now. And if I start looking through the pages, I'm going to see the course structure, okay? So this is a 12 credit point subject. And what does that mean? 12 credit point means that you need to do 10 hours a week of introduction to mechanical and automotive engineering. So the way I've broken it up is that we have 2-hour lectorials every week. I'll be providing some video recordings beforehand. So we have 2-hour lectorials. I'm running 5 lectorials a week. So if you don't understand something from one class, you can jump into another class. No, you can't. The question is there any way I can order a physical copy of the book? No, but if you're on campus, I shouldn't really say this out loud, but I can print it out for you. Just don't all do that. You can print it on campus, it's fine, it's no problem. I suggest you actually print it out. It's a great reference book, even for next year. So yeah, we have 2-hour lectorials, which I'm running all the lectorials, so you'll see me for 2 hours at least a week. I will be running, we have 2 hours of tutorials every week, which you have tutors for, and your tutors will be hopefully running right now, since we're in COVID, lockdown in Melbourne, your tutors will be running your tutorials on OneNote in Collaborate Ultra, so just go to your Collaborate Ultra session. And again, if you don't understand something in one tutorial, go to another tutorial. Everything's online right now and everything's accessible. And then finally, we do a 1-hour workshop every week. And we have a lot of tutors actually working in that space. So that's 5 hours a week from me, which means you guys need to put in 5 hours a week of work. Okay, this is not an easy subject. It goes very quickly, very fast. And you miss 1 week, you're just stuck. You just cannot move on. So that's the course structure. Let's take a look at the planning and the time management for the course. Are there any questions, guys? So if you take a look at the course structure, well, first of all, the textbook that I have taken all the material out of for this semester is the Hibbler, Statics and Mechanics of Material. I actually use version 4 and 5. It doesn't really matter which version you use, they're all exactly the same, and every university uses the same textbook. This is a great reference material. All my questions come out of here, everything comes out of this book. And it's available probably in the library. So when you take a look at your course structure, like for week 1, that's this week, we're looking at 4 systems and moments, and we have a reference chapters from the textbook. So in week 2, so next week, we start looking at equilibrium. Week 3, structural analysis, and that's where we'll be looking at how to analyse your bridge, your truss bridge. In week 4, we look at internal loading. Week 5, stress and strain, which is actually a very important topic because in week 7 to 9, we actually do a laboratory on stress and strain, and you'll be doing that in your workshop group with your designated group. Then in week 6, it's going to be a revision week or a catch-up week, where we will also have our 20% online mid-semester. Then we have a university break. In week 7, we start looking at axial loading. Week 8, centroids and moment of inertia. Week 9, bending moments and flexural formula. Week 10, torsion. And week 11, we start looking at stress transformations. And then finally in week 12, we actually do our big, we do our presentations for our design studio. which is a 7-minute presentation, which I'll go into further later. So then, what else do we have here? Okay, let's take a look at the assessments for the semester. So, for those who have had me last semester in first semester this year, you'll realise that I'm pretty easy about a lot of things, and I have a few rules, but after that I just want to be able to have a really good class and enjoy learning mechanics together. So there are 534 students in this class, so that's a really big cohort. All assessments are on Canvas, so pretty much you'll be going to Canvas for all your assessments. All submissions must be uploaded to Canvas. Okay, you cannot email me your assessment, because with 534 students I will never find it. Okay. All submissions must be in PDF format. Because of, again, the large cohort, it's really difficult to mark so many papers if you keep opening up different file formats. The question is, will we meet you back at the campus when the lockdown is over? Yes. When lockdown is over, I will not be in front of this camera. I'll only be in front of this camera for pre-recorded lectures, but I'll be face-to-face in the lecture theatre. And I can't wait. I love being on campus. Next, late submissions will be penalised. That's university regulations. Another university regulation is if you miss an assessment, you'll need to apply for special consideration. And finally, there is really one rule in this class, and you can't cheat. Okay? I don't want to see my material up on any paid website. I don't mind, and I actually highly encourage you guys to work together as a group, and I don't mind if you do your quizzes together or any of your assessments together. It just must be, you must hand in your own work, okay? It is great to do your tutorials in a group, it is great to study in a group, and I encourage you to meet the other guys in your class. Do you guys have any questions? No questions? The next part is what's the assessment breakup. So in week 6 we have a 2-hour mid-semester, and that will be open up for 1 week. So once you start the mid-semester, you only have 2 hours to complete it in, and that will be a written paper online. Everything's recorded. If you go onto the YouTube channel, the question was, are these lectorials recorded? If you go on YouTube, you'll find every single lectorial from this week. And in actual fact, what I am going to do next week is, because I didn't realise that we're still online, next week, because I'm giving a lectorial 5 times a week, next week I'm going to actually make different questions. So every lectorial class will have different questions. So then if you want to watch the video from Tuesday or from Wednesday's class, you can actually see and solve different problems, which that actually could be quite helpful. Does that answer your question? And then we have we have some online quizzes. So basically we have 4 online quizzes, and these are in week 3 and week 5. And so basically what I've done is I've put 2 online quizzes before the mid-semester, so then you can have some practice questions and give it a go. You'll get 2 goes at these questions, and all the instructions are online when you actually do them. In week 5, you'll have a 5% quiz on structural analysis and internal loads. And then you'll do your mid-semester exam. And then in week 8, you'll actually do a 5% quiz on stress and strain. And the reason for that is I need to make sure that you guys know and understand stress and strain before you do the tensile testing laboratory. And then in week 10, you will have a quiz on bending moments. So basically, I've just tried to pick out some of the really important things that you need to know for this semester, and being able to do a refresher and make sure that you do understand it before the final exams come up. And then your next assessment task is a 40% final assignment, and I haven't confirmed the date of that yet. I'm waiting to see how many other assessments you have during that time. So I will not put this assessment on when you've got, material for 5 other classes to do. Then finally, you have your design studio will actually be worth 20. And this is a group project, and you'll present in your group in week 12, and it will be a 7-minute presentation. And I'll give you a format and a PowerPoint presentation of exactly the format to follow. Okay, it will be very structured, it will be very quick, and but it has to be very informative. So you have 7 minutes to tell me exactly what you need to tell me, what you've done for the semester on the project. You must turn up to the tensile testing laboratory. If you don't turn up to the tensile testing lab, you will not get the marks for that component in your presentation, in that 20%. If one person doesn't turn up in the laboratory, in the group, just that one person will lose the marks. Yep. Do you guys have questions? I feel like I've been talking non-stop. Questions? Any questions, guys? Are you all good? Anybody? No? Gosh, you guys are very quiet. So I'm just hoping that all the assessments are okay. All right. No problems? Cool. Do you have any questions for me about the course or accessing the material? And if you actually take a look at the front page of Canvas, it actually says that the studio workshop book is not available until week 2. So yeah, keep an eye on what it says on your front page of Canvas. And the next thing is there is a discussion board on Canvas, which is, I can't see that far, but I think it's one of these tabs. And I actually posted up a discussion this morning just to let you know that it's all working. Guys, I'm just going to say that you're at university now, and it's great and it's fantastic, but you're also adults. So if you want to attend lectorials or tutorials, that is your choice, but I can pretty much guarantee if you're not turning up, you're not going to do great. And watching videos purely and not actually going through the problems is when you've got no help and you're not asking anybody for help. It's not that simple. Okay, for our final, will it be online and we'll be able to use our notes? Yep, so the question is, for our final, will it be online? Yes, your final will be online. You'll have 1 week to do it in, and you'll be able to use all your online notes, your OneNotes from your tutors, all your material. It's open book. Does that answer your question? Oops. So, has anybody accessed any of the videos so far? I'll give you a minute to answer that. By any chance? Have you accessed? Has anybody had a look at any of the videos? Right. Okay. How you going, guys? Labs will be carried out. So the question is, labs will be carried out in the workshops. Yeah. Tutorial sessions are purely for solving mechanics problems. Tutorial questions are purely for solving problems in this book. Yep. All good? So you've seen some of the videos already? Has anybody seen what this room looks like and how I'm doing this? I'm not sure. So I'm going to jump off YouTube for a couple minutes in a second, and when we come back we're going to have a look at resultant forces, and we'll see, and we'll do a couple questions. So I'm going to jump off this and go back onto Collaborate Ultra. Hi guys, was that clear? Is it alright? Are you happy with it? You can actually speak to me in real life if you like. That would be lovely.
Yeah, well, there was a bit of delay, so you're still on YouTube for me now.
Oh yeah, there is a delay between YouTube and Collaborate Ultra. But I need to use Collaborate Ultra because I don't want all your comments and your names coming up on a live stream or in a recording. Yeah. Two teachers that look exactly the same? That's interesting. Yeah? Does anybody have any questions for me whilst I'm on Collaborate Ultra? Anyone? No? Oh, hang on. Is it on now? Alright, so, yeah, what's your question? Questions? Hello? Anyone there?
Yeah, quick can hear you, but doesn't seem any questions for now.
Someone's got a question. Someone actually says I've got a question. Did you want to ask your question? Yes, you'll be assigned into groups. Not by me, by the tutors. And it'll just be random. And the reason for this is you get to meet other students, and in real life, when you're working as an engineer, you don't always get to choose who you work with. What are you presenting? You're presenting your trust bridge. Yeah? You'll find out more about that next week in your workshop. I'm an online. Yes, of course. Online students will be on the Monday class. The workshops for the online students is at 12:30 on Monday, and you'll actually be working in a group with students that are here on campus. But at the moment, everybody's online, so it doesn't really make a difference. Yeah? Did that answer your question? Was the material easy to access, guys? And clear? Cool. Great, because I don't want you to be downloading material every week. That's awful. I'm just waiting for anybody to respond. So, are you ready to do some questions, guys? You got no problems with the course and the course structure? Is that Flynn from who was in my class once upon a time? Hi. All right. Okay, let's go do some problems. Yeah? Cool. I'm going to turn this off and we're going to go back onto YouTube, so there'll be a slight delay. Actually, have you guys seen the room? Have you guys seen how I'm doing this? Look at this. So it looks like I'm writing backwards, but I'm not really. So on YouTube, there's actually a video of this whole room. So basically, I've got a light board, and I have some studio lights on all sides. And on my light board, I actually have a strip of LED lights. And then I can actually write. And then I have a camera and another computer down there. And that software actually flips the video for me. So yeah, that's how we're doing it these days. That's how the cool kids are running. So I'm going to turn this off, and please ask questions if you need any help. Okay, we're back. So let's take a look at resultant forces. So what is a resultant force? A resultant force is the summation of all the forces acting on a system. So if I take a look at this question right here, the question actually asks me, and this question is in your tutorial book, and it is on page 3. And the question, it's question F2.8. Can you find that, guys? So let's take a look at this problem. It's page 3 of your tutorial book. So the question asks me to determine the magnitude and the direction of the resultant force. So what do I need to do? I need to add up all these forces and I'll get the resultant force. So if I call this F1 and this force F2 and this force F3. Okay. So force is a vector, right? So force has magnitude and direction, okay? So that means I need to find the x and the y component for each force and then be able to add them up. So if I put a little axis here, x and y, everything on this side of x is positive and everything on this side of y is positive. So we can take F1, and F1 only has an x component, so we're going to say F1x is equal to 300 newtons. And then if I take F2, and if I draw a little axis down here, and I draw my force, okay, and my force is 400 newtons, and it's at an angle of 30 degrees. I need to break that up into x and y components. So my x component is going to be 400 cos. Do you guys remember your trigonometry rules? 30. And my y component is going to be 400 sine 30. Yep. So what I'm going to write here is f2x is going to equal, it's positive, 400 cos 30, and f2y is going to equal positive 400 sine 30. You guys with me? And then I'm going to take my final force, which I'll draw down here, and it's going this way, and it is 250 newtons. And down here I have, it's got a little trigonometry triangle, 5, 3, 4. So now I can break that up into my x and y components. So x is going to be negative, y will be positive. On the x we're going to have 250 times 4 on 5. And on the y we're going to have 250 3 on 5. So over here I'm going to write f of f3x is going to equal, what do we have down here? Minus 250 4 and 5. And in the y I'm going to have f3y is going to be 250 3 on 5. So, to find the resultant, I'm going to add up all the x components and then all the y components. So I can say that some of the forces in the x direction, so let's assign this to be positive, is going to equal 300 plus 400 sine, no, it's 400 cos 30 400 cos 30 minus 250 4 and 5. And if I add that up, I'm going to end up with some of the forces in the x direction is going to equal 446 newtons. And since it's positive, we know that it's going this way. Then, if I do the same thing for the forces in the y direction, so I can say some of the forces in the y direction is going to equal 400 sine 30 plus 250 3 on 5. So if I add all this up, I'm going to get some of the forces in the y direction is going to be 350 newtons. And which direction is it going to go in? It's going positive, so it's going this way. Alright. Can you explain? Yes, I can explain that. Alright. So the question here was, can I explain this triangle? So this is a trigonometry triangle. I'll just draw it up here. So this is Pythagoras. Okay? So this is like saying, it's like calculating theta in here. So I could also do theta equals, so it's this angle in here, tan to the minus 1, 3 on 4. Yep. Is the same as writing the x component of this is going to be, so that would be equivalent to writing, we have x and y components. So the x component and the y component. So the x component will be 4 on the hypotenuse, so 4 on 5, and call this f. And this one will be 3 on 5. 5 times f. Yep. So that is the same as just actually calculating your angle out theta. But the ratio, this is your trigonometry ratio, is actually more accurate than calculating it out, and it's faster. It's one less calculation. Is that good? Good? So now I can actually calculate. I know what f of x is. I know f of y. So now I can actually summate these two forces and end up with a resultant force. Alright, just have a bit of room here. So, let's do this. So we know that sum of f of x is going in this direction. The sum of f of y is in that direction. How do we find the result of vectors? We need to put this one over on this side. And then we can find head to tail. This is going to be my f resultant. Yep. Now we can say that my resultant force is going to equal the square root of some of the forces in the x direction, all squared, plus some of the forces in the y direction, all squared. And just expand that out. So we're going to have 446 squared plus 350 squared. And my resultant force is going to be, I think it's 567 newtons. You guys got any questions? Got any questions, guys? There's one more thing to solve. Because vector force is a vector, so we've got the magnitude, we need to find the direction, theta. So what is theta equals? Theta equals tan to the minus 1. Opposite on adjacent, so I have some of the forces in the y divided by some of the forces in the x. And I'm going to have tan theta to the minus 1 is going to be, which one's y? You have 350 on 446, and so theta is going to be 38 degrees. So this angle here is 38 degrees. Is that clear? That's good? How are you guys going? This is Pythagoras, yes. Cool. Is that simple enough, guys? Simple? Let's go on to something a little bit harder then. This is too simple. I'm just giving you a moment. Alright, I'm going to clean this whiteboard and hopefully you'll have caught up with me by then. let's take a look at, it's hard work cleaning this whiteboard. Alright, so let's take a look at moments. Okay, let's take a look at moments. So, what is a moment? So a moment is a turning force. Let's look at moments. So a moment is a turning force. So, you know how when you change the tyre of your car, when you have a flat tyre, and you've got a hubcap and you have all the bolts connected to it, and you get a ratchet and you put one end onto the bolt, and then you need to actually apply a force to push it down to actually make the bolt turn, to release it. Well, that is what we call a moment, that rotational force. So, it's a turning force. So, the moment is equal to the force times the distance. And we'll talk about the distance in a moment. So this is force, and this is distance. And this is not any distance. This is the perpendicular distance, to the force. Okay, so, you with me? So if I have my pen and I'm holding it and it's fixed on one end, and if I apply a force downwards to it, it's going to go in this direction. If I take my pen and I apply a force upwards, it's going to go in this direction. Interestingly, if I apply a force directly on the end of the pen, it's not going to rotate, and we're going to look at this in a moment. So, let's take a look at units for moments. So force, the units is newtons. For distance, the units is meters. So the units for my moment is Newton meter. Just lost connection. Yep. So let's take a look at a question. It's going to be the simplest way to do this. And this question is in your tutorial book. So this is question P3.1, and it's on page 4. My moment and a talk is the same thing. Okay. So, let's take a look at this question. I'm just going to redraw that diagram over here. And here I'm fixed at a wall, 0. And I have a force acting on it, and it's 100 newtons. And it's given me some distances, and the distance is 2 meters. So if I wanted to find the moment around this point 0, I would say moment equals FD perpendicular. Let's take a look. We know what F is. We know that F is 100 newtons. But what's D? D is the perpendicular distance. So this force is perpendicular to this distance. Therefore my perpendicular distance is 2. You guys good? So then my moment equals 200 Newton meters. And we need to assign the direction. So for all these problems, I didn't write it up here yet, the moment is a vector and it has direction, and we are always going to say that this force is moving in this direction. And we have said we're going to assign that anything going in this direction, the moment is positive, and anything going in this direction, the moment is negative. Yep, so here we have our point and our force is rotating around. You guys good with that? So this is our sign convention. Just like when we assign x and y. Yep. So here I'm going to include my direction. This is a positive answer, therefore my moment goes in this direction. Alright, I'm just going to do a couple more of these problems and then we'll do something harder. How you going, guys? Let's do another problem. I need a better way to clean this light board. Okay. Is it wrong if we flip the positive and the negative? Okay, the reason why I always assign positive in one direction, you don't want to. It's like saying that because all the problems in this class, I'm assigning positive to be in this direction. It's like changing your sign convention of this. Yeah? This is the convention. This is our convention. And it just keeps it simpler for the whole semester and for next year, because it's the same convention that we use. Okay, let's do another problem. Alright, so this is problem 3.1D. And what are we going to do? So we want to determine the moment around point 0. But now we have this force, and we need to actually break up this force into its horizontal and vertical components. Okay, so down here, I'm going to redraw my force, and I'll put it on an axis. And we have this triangle again going on. We have 4, 3, and 5. And I'm going to break this up into horizontal and vertical components. So on the horizontal, we have what's the force? 500 newtons. So we have 500, and on the x we have 3 on 5, and in the y direction it's going negative. We have 500, 4 on 5. You good? Is that right? So now I've just broken that into x and y. So let's just draw our diagram again. And we have the 500 newtons. Actually, that's all right, I'll leave it there. And it's my point 0. I have my, let's just draw axes here, x and y. I have my 500 newtons for my y component, and I have my x component, which is 500, 315. So what else do we have on this diagram? We need to put our distance in. So this is my distance, and it's 3 meters. And, right, let's have a look. So I want to find some of the moments around this point 0. So I can say that some of the moments around 0 is going to equal the torque or the moment produced by this force plus the torque produced by this force. So let's do the vertical first. So we're going to have 500 4 on 5, and this is going to go in this direction, so we need to assign our positive here. So that's positive. That's positive, so we can have a positive. And our perpendicular distance of that force here, which has a little perpendicular distance there, is 3 meters. I'm just checking if there's any questions. Then, if I look at the x component, guys, tell me what is the perpendicular distance of the x component to point 0. So plus 500, 3 on 5. Any takers? My perpendicular distance is actually 0 because this force is acting through my point. I'm just waiting for you guys to catch up. So that means the horizontal component of our 500 newton force doesn't contribute to the moment. So some of the moment around 0 is going to be, I haven't calculated this out, is going to be 1,200 newton meters, and it's positive, so it's going in this direction. Are there any questions, guys? Any questions at all? I'll just wait for you to catch up. Okay, now I think we should just have a quick little break. I'm just checking in on you guys on Collaborate Ultra a little bit because it's the first session. And then we'll do a really hard question and put it all together. And I'm going to put the next question up. Yep, that's not it. That's it. Alright. Oh, the question is, why is it 0? Oh, let me answer this quickly. So, if this is my beam, and I have a point here, 0, and if I put a force is going here, my beam is not going to do anything. It's just going to be compressed. Yeah? This force is going through the line of action. Actually, this is my line of action. And it's going through my point 0. But if I had my force here, then I have a perpendicular distance, and that's going to rotate this way. If I have a force going this way, it's going to rotate around this point this way. Yep. All right. Hi guys, I'm on Collaborate Ultra for a minute. Does anybody want to, is that okay? How are we going? Guys?
Yep, it is okay.
All okay? All good? Just checking in on you to make sure that you're happy with everything and it's all right. And all good? All right. It's not too hard? Cool.
So I was just gonna ask, like, before I joined the lecture, there has been some, you posted already some videos, it says pre-recorded lecture for week 1.
Yes?
But there has been nothing about MIET in it. There was like a deleted video. I don't know if that video was supposed to be about MIET.
No, there was a, no, I didn't post anything up on Moments yet.
Oh, okay, so
But if
I
you
was just
actually,
making sure.
pardon?
No, I was just making sure because there was a video deleted, so I thought that could be by mistake, like MIET.
No, no, I haven't uploaded. I thought I'd just do that today. It's a pretty easy session. The next question is going to be harder, but for next week I've got lots of videos coming up for Monday to have a look at. But basically you really need to know how to solve moments. The videos are on my YouTube channel. Does anybody have the link? You could actually just Google my name and it will come up. How cool is that? Does anybody have where's the link? I'm just trying to find the link. And the link is always in Collaborate Ultra, right? Oh look, everybody sent it. It is on Canvas, all the chat is on Canvas, and the video is on YouTube. And the reason for that is that I just don't want all your details coming up on the YouTube. Yeah? Is that cool? I'm just going to go get a cup of coffee and we're going to do the problem on the light board. Yeah? Are you good? Cool. Everybody happy? I like happy students. Cool. Alright, And if you've got questions, just ask. And everything that I'm talking about is actually in your lecture notes, so you can also take a look at those notes. Okay, let me just clean this board up. Okay, so before we start looking at this question, let's just take a quick look at distributed loads. So what we have here is actually what we call a distributed load. It goes across the whole beam, and sometimes it just goes through for a section of the beam. And let's just take a look. So a distributed load, and what do we do with it? Okay, so the unit for distributed load is newtons per metre. Okay, and we need to turn this distributed load into a concentrated force, so then we can solve the problem. So we want to turn it into newtons. Yep. So we need to work out what to do with this metre. Is the audio very quiet? Is that better? Is that better, guys? Let's move the speaker. Okay, so we want to take a distributed load and convert it into a concentrated force. So our units for distributed load is Newton per metre, and we want to turn that into newtons. So no change. Is this better? Is that better? So this is what we have. So if I have a beam and I have a distributed load that looks like this, and we can call that 10 kilonewtons per metre. I want to turn this into a concentrated force. I have a beam and it has a length of 2 metres. Okay? So, how we solve this is a rectangle here. Yep. And so the area is equal to a rectangle. So the area of a rectangle is the length times the height. So the length is 2 metres and the height is 10 kilonewtons per metre. Okay? So if I cancel out my metres, what am I left with? Just the kilonewtons. So I have 20 kilonewtons. So this is my concentrated force. So my concentrated force is going to be somewhere on this beam, and it's going to be at the centre of the beam. So where's the centre of the beam? centre of the beam is at 1 metre. Is that clear? So now, if we take a look and we turn this distributed load into a triangle, what's it going to be? So now, if I take the same beam and I have a triangular distribution, and this is 10 kilonewtons per metre, and this is 2 metres. What do I do? I can say that, what do we have here? Our area is the area is a triangle. And what's the area of the triangle? Is half base times height. So I have half, the base is 2 metres, and the height is 10 kilonewtons per metre. My metres cancel out, I'm left with kilonewtons, my 2's will cancel out, and I'm left with 10 kilonewtons. So this is my concentrated force. So where does the concentrated force fit on this triangle? So the concentrated force is going to be at the centroid of the triangle. So this is the centroid. And the centroid of the triangle is at a distance of 1/3 times the length. Yep. So you've got to remember centroid. So my concentrated force will sit here at 10 kilonewtons. And that means my distance is going to be 2 on 3 metres. And that's it. That's all we need to know about concentrated force. So we have a distributed load and we need to turn it into a concentrated force. All right. So over here on this diagram, what do we have? We actually have 2 triangular concentrated forces. So we have one here and we have one over here, because they need to be right angles. Yep. So let's clean this up and solve the question. Okay, so the question, let's read the question first. So this is question 3 in your tutorial book, 3.108, and that's on page 7. And the question says, replace the distributed loading with an equivalent resultant force. So what are they asking us to find? So they want us to find F resultant. Need to find that. And it also wants us to find and specify its location on the beam measured from point 0. So that means that wants us to find D perpendicular. So how are we going to solve this? We can say that M at 0 is going to equal FD. All right, so the first step we're going to do is we're going to calculate M. But before we calculate M, we need to work out what the distributed load is into a concentrated force. Otherwise, we can't solve it. So let's take the first triangle. So the first triangle is going to be here we have 3 kilonewtons per metre, and it's over a length of, let's just check, 3 metres. Okay, so we're going to turn this distributed load into a concentrated force. So the first thing I'm going to do is, it's a triangle, so the area of a triangle is half base times height, so the area equals half the base times the height, and it's going to be half the base is 3 metres, the height is 3 kilonewton on the metre. My metres will cancel out and I'm left with kilonewtons, so I'm going to have 4.5 kilonewtons. So I'll have my force will be here, my concentrated force at 4.5 kilonewtons is going to sit 1/3 from the heavy side of the triangle, that's my centroid, so it's going to be 1/3 times 3 metres, which equals 1 metre. Okay, let's take a look at the other triangle now. So for the other triangle, what do we have? Let's just draw that up. Let's draw it over here. We have a distributed load and it's over a distance of 1.5 metres. You guys with me? Got any questions? This is 3 kilonewton per metre, so that's the height of my triangle. And again, it's a triangle, so we have our area equals half base times height. So it's going to be half the base, which is 1.5 metres, times 3 kilonewton on the metre. So what am I going to have? My metres will cancel out again, so I'm left with kilonewtons. I always write my units so then I can make sure that I've calculated the correct thing. And this becomes, I believe it's 2.25. It is 2.25 kilonewtons. So here I have my concentrated force. Where is it going to sit? It's going to sit 1/3 at a distance of 1/3 from the heavy side. So here, 1/3 times 1.5 metres. So that's going to be at 0.5 metres. Okay, let's redraw that. So over here, we're going to have our diagram. Here's our point 0. I have two forces. Here is my 4.5 kilonewtons, and here is my 2.25 kilonewtons. And we need to work out what the distance is from the point 0. So what is that distance? So the centroid of this triangle is at 1 metre from the heavy side. So this here is going to be 3 minus 1, which is 2 metres. And the 2.25 kilonewton force is going to be at, it's at a distance of, here we have 3 metres plus the extra 0.5. So we're going to have 3 plus 0.5 metres, and so it's going to be 3.5 metres. You guys good with that? I'll give you a moment to catch up, and I'll just clean this part of the board. So now we have just taken our problem and reduced it to a simplified problem that we can actually now calculate our moments. Okay, So now we have our diagram. We know what, we can calculate our resultant force. How do we calculate our resultant force? We can calculate the resultant force by saying that some of the forces in the x direction, there's no forces in the x direction, so that's going to be 0. And then some of the forces in the y direction is going to equal minus 4.5 minus 2.25. So that means some of the forces in the y is going to be minus 6.75 kilonewtons. So if we do Pythagoras, we can find that our resultant force is going to equal the square root of 6.75 squared plus 0 squared. So our resultant force is going to be 6.75 kilonewtons. And it's positive, so it's going up. No, it's not. Here it is. It's going down. Okay. So we have our resultant force of FR. Which part? I'm just waiting to hear back. Did you want me to re-explain the resultant force? Going through this quickly. So what is the resultant force? The resultant force on this system is the summation of all the forces acting on this body, okay? So I know to find the resultant force, I need to add up all the forces. I know that there are no forces in the x direction, okay? I can add up the forces in the y direction, and so I'm going to add up this force, and that will be the sum of the forces in the y. And then, this is just an extra step which was unnecessary. I could have just worked it out from adding up these two forces, that it was going to be 6.75 kilonewtons. Okay, so now I have the resultant force. We need to find out what the moment is. I'm just going to clean up this space. Actually, I don't need to. So the next part is we need to find, I'm going to put this as my positive direction, some of the moments around 0 is going to equal. Okay, so let's take a look. Are you guys asking about the triangle distributed load? So here's my distributed load of the triangle. Here's my beam. And I need to turn that distributed load into into a concentrated force. That's what we've been doing up until, and that's how we go here. Okay, so now we have our two forces from our distributed load, and we've converted them both into a concentrated force. So if I go onto this diagram here, what am I going to have? What will it look like? It's going to look like, let's see if I can draw this. I'm going to have a load here, and can't see that very well, a load here and a load here. And that's going to be my 4.5 kilonewtons, and that's going to be my 2.25 kilonewtons. So that's how this diagram relates to this diagram. Yep. Can you see that? So I've converted these two distributed loads into two single forces, which I've got over here. So now I can find the moments around A, 0. So this force is going to go around point 0 this way. Let's just draw that again. My pen doesn't want to work right now. Yep, so we're rotating around the point, so that's going to be negative. And this force is also going to go around in this direction, which is also negative. I think my green pen's given up. So, some of the moments around 0, I'm going to have 4.5. My perpendicular distance of that force is 2 metres. It's negative. And then this one's also negative, so I'm going to have 2.25, and my perpendicular distance is 3.5. So if I add all that up, I can say that the sum of the moments around 0 is going to be minus 16.9. Are we in kilonewtons or just newtons? Kilonewtons. So it's going to be kilonewton metre. And this negative sign here means that it's going in the other direction. So that means you're going to have 16.9 kilonewton metres going in this direction. So if we go back up to this equation here, we have the moments. So now I can calculate the position that my resultant force sits on that beam. So I can say that sum of the moments around 0 has to equal F resultant D perpendicular. So that's going to be 16.9. Our resultant force is 6.75, and I can calculate my perpendicular distance. So my distance is going to be 2.5 metres, and that's from 0. So if I want to draw it on this diagram, again, my resultant force is going to be here, F resultant, and this distance is going to be 2.5 metres. How's that? It's pretty good, right? What do you think, guys? Is that clear? That's our answer.